They say that machine learning is 90% pre-processing and 10% modeling. I think this is a good approximation of our work in this case, too. And now it's finally time for the modeling part. As usual, let's import the libraries we are going to use. We've tried to construct this regression with stats models and sklearn. However, stats models could not provide an answer. That's because whenever we are training a machine learning model, there are many mathematical issues arising in the background. Imperfect libraries such as stats models are not always numerically stable for more complicated models. That's why we had to turn exclusively to sklearn. I've never been let down by it before, and such was the case this time too. With this clarification in mind, let's import the relevant modules. Since we are building a logistic regression, we'll need to import the logistic regression module from sklearn.linearModel. I will also import the metrics module from sklearn because it will prove quite useful when evaluating the model. All right. Now we must declare a new variable which will be a logistic regression object. To do this, let reg be equal to logistic regression parentheses. Next, we must fit the regression. We simply write reg.fit and in parentheses xtrain and ytrain. What this method does is basically all the machine learning. Let's run it. Instead of something spectacular, as an output we get all the parameters of the logistic regression object we specified above. Obviously, they are all the default ones since we didn't specify anything. Each of those parameters has a special meaning which can improve our model one way or the other. As usual, we will discuss this in a separate lesson. For now, let's focus on the results of this regression. It is easy to evaluate the model accuracy. All we have to do is type reg.score. There are two required arguments, inputs and targets. Once again, we input xtrain and ytrain. The result is around 0.80. We conclude that our model has an accuracy of 0.8 or 80%. In other words, based on the data we used, our model learned to classify 80% of the observations correctly. While sklearn is very useful, in order to truly understand the result, I want us to find this accuracy manually. This is no small segment, as we will be basically building the score method we just used from scratch. That's needed for two reasons. One, it is always good to have the full understanding of what we are doing, and two, we will be using this idea later on, so we might as well start now. Alright, first, what does accuracy mean? The logistic regression model is trained on the train inputs. Based on them, it finds outputs which are trying to be as close to the targets as possible. However, accuracy means that 80% of the model outputs match the targets. So, if we want to find the accuracy of a model manually, we should find the outputs and compare them with the targets. Let's do that. In order to find the model outputs, we will use a simple sklearn method. It is called predict. So, if I write reg.predict xtrain, this method will find the predicted outputs of the regression. The model itself is contained in the variable reg, and we are choosing to predict the outputs associated with the training inputs and contained in xtrain. Let's store all that in a new variable called model outputs and see what's inside. We can see an array with zeros and ones. These are the predictions of our model. Let's also display the targets and compare the two. The two arrays look alike but have many differences, although it is hard to see them with the naked eye. Let's use code then. If we write model outputs equals ytrain, we will get an array which compares the elements of the two variables. If there is a match, the result is true. Otherwise, it is false. Now we can clearly see which elements have been guessed correctly and which haven't. But how many are there? You know that true is the same as 1 and false is the same as 0 in Boolean, so let's sum this array using npSum. The result will be the total number of true entries. If we divide the number of matches by the total number of elements, we will get the accuracy. We can find the total number of elements using model outputs dot shape 0. So let's divide the number of true entries by that. What we get? The exact same result as using the sklearn method score. However, this time, we have a much better idea of what that result means. Alright, in the next lesson, we will dig even deeper, exploring the coefficients. See you there!